Hello everyone. We are on day 21 of the challenge. So the problem for day 21 is to fine tune and evaluate autoencoder model for anomaly detection that we have we started this training this model yesterday only. We prepared the data, we did data preprocessing, and we have set up the model. So if we go and look at the code, the code is there in the yes the code is there in the git repository also. But if we go and look at the code, so we have prepared the data, and we have also trained the model. We have trained the model on the normal data only the data only. If we go and check this, only the normal data. And what do we mean by normal data? The transactions which are not fraudulent, normal transactions. So the idea is that if now we are going to test it on the all type of data. If the loss is going to be huge while reconstructing after compression, it is an anomaly, otherwise it is a normal transaction. So this we understood yesterday. Now if we start for what we have to today, I'll use the same context window of ChatGPT. I'll say, hey, it is day 21, and uh, hey, it is day 21, and today we have to do fine tune and evaluate for anomaly detection. Yes. So let's see what ChatGPT has to say for this. Can you give me a second, please? Okay, sorry, I had to cut it because I felt that there is someone at the door. So yes, if we come here, we see that yeah, the step number one is to fine tune the model. Um, okay, so yes, so step number one is to fine tune the model. So, and then we are going to determine the construction error threshold, and then we are going to evaluate the performance. So let's read what it says for step number one. It says that fine tuning involves tweaking the hyper parameters to achieve better results. We have done this before. We explored and experimented a little with the hyperparameters. For anomaly detection, we want our model to learn to reconstruct normal transaction well, while distinguishing anomalies by their high reconstruction errors. Here is how we can proceed. So increase or decrease model complexity. Okay. Depending on how well the model is learning, adjust the number of layers and neurons. Okay. We need to, depending on the number of, on how well the model is learning, depending on how well the model is learning, okay, we will adjust the number of layers and neurons. We will adjust the number of layers and neurons. Okay. Experiment the learning rate, and then we will experiment with the learning rate. So first we will be experimenting with the number of layers and the neurons count, and the and then we will experiment with the learning rate. The Adams optimizer's learning rate can be adjusted to fine tune the speed of learning. We did that, we did something similar in the past also. If to give you surety, if we go back to like the week number 1, on the day 7 we did fine tune hyperparameters with Keras tuner on a small neural network. So it is going to be something like that, but we did not do it on the convolutional neural network. But yes, it is going to be something similar. So what are we doing? This we did yesterday only. This we also did. No, we are adding. If we see that we are adding. So yesterday from the code, if I come here and I see that we had a layer of 14 and then 7, and then while constructing back we had a layer of 14. Now today we are going with 10, 20 layers, and then further decreasing the dimension, compressing, which means we are compressing further with 10 neurons, reducing the size further. And then the and then we further reduce it, because we this is the latent code, this is the latent representation to capture the key patterns, and then we decode it, we reconstruct it back. We start with 10, and then we go to 20, and then this is the final layer, where we reconstruct to the original input, which is this one. So let's come here and update this. So earlier we went with 14, today we are going with 20, then we'll go to 10, and then we'll have the latent code, which is latent representation to capture the key patterns. Okay, so add it, then 5, yes, activation. While I'm solving this, I have got one more idea. After capture, so let me talk about it once I will be done with solving this thing. Capture, so there was a typo. Now we'll decode it layer. So we'll start with dense layer of with neurons 10, an activation function, rectified linear unit. Then we'll go from 10 to 20, and then we'll have to go from 20 to original input, which is the this is the original input. So reconstruction original points, original input. Okay, so let's come here, give one space, and we'll use the linear activation function. So we have added 2 3 layers today, fine tuning with experimenting with the number of layers and the number of neurons. Now we will experiment with the uh, by adding the what, first we are increasing the number of epochs. So how many we are increasing the number of epochs to 100, then we are decreasing the batch size, which means we will cover small size, which is also a good sign. It will the training will become a little slower. So this is what we are doing to do today. then then we will do what, once the auto encoder is trained, we will do what, we can use it to reconstruct the input and calculate the reconstruction error for each transaction, and we use this error to classify transaction as either normal or anomalous. So what are we doing, we are, once we have the trained model, okay, now we are using that trained model to predict on the x validation, this x validation is the data that the model has not seen. Now what are we doing, we are, this when this model will throw the uh, so I have already spoken about it yesterday only, but let's code it first and then I'll speak about it. So let's do what, calculate reconstruction error, calculate reconstruction error, test prediction x validation data prediction is going to be the model dot predict on the x validation. Now we have to calculate the mean square error. Calculate mean square error for each test sample. Calculate mean square error for each input sample. So mean square error will be, oh, we are calling that as the reconstruction error. Reconstruction error. So what are we getting? So what are we doing? We have got the prediction information here. So we'll get the uh, Oh, we are doing. Can you? I'll say if I'll simplify this. This is um, x minus the validation minus the x predicted. This x validation data predicted. Okay, uh, and then we raise it to the power of 2. Okay, and then we get the okay mean squared error. We are getting mean, so this is the mean, right? And then we are getting the mean squared error, and then we uh, get the mean of it. Okay, let me ask. Yes, it calculates the square of the differences for every feature of each sample. It helps in making sure that the negative and positive references do not cancel each other out, and it gives more weight to the larger error. Okay, so it helps in giving more weight to the larger error. We are doing it because we do not want to cancel out the negative and positives. Mean we are doing to average out the error. So it is this. So let's do that. Let's construct it. First, we'll calculate x validation minus x validation prediction. Now we'll do what? np dot power it to 2. Okay, and then we'll do what? We are doing it on axis. Now we have got this. Now we'll mean it. We are adding the mean on the columns, on each column, right? Okay, so this was what it was trying to say. Correct. If we want, if we can see the x value prediction also, so let's hide this visualization and see what is more there. We need now we are setting a threshold also. Then we are making prediction and evaluate performance. But before that, I am curious to know what it is there. What is there in the uh, prediction? What is there in the x value prediction, and what is the construction error? So I'll say reconstruction error. So let's run this. Sorry, not add it. Run this file A20. If it will take more time, then I'll prefer to code the application first. Okay, it might not take that much time because it may take max to max 1 minute. So we are already on the 34th. Okay, we are on the 60th epoch. Okay, we are almost done. So we are done with the training and information, and this is how the validation looks like. This is the output for the first input, as in first transaction details. Then this is the output for the second transaction, the loss. Then this is for the third, fifth, sixth, seventh, and this is how it is. And what are we printing next? I printed this next, uh, this reconstruction error. So I don't know, maybe it did not. Yeah, I don't think we did see the reconstruction error. So let's do what? Let's comment it out for now. I will see this reconstruction error later. So let's go and then go ahead with the other steps. What do we need to do? We need a threshold to classify transaction based on their reconstruction error. You can determine the threshold using the different approaches. First approach is quantile method. The quantile method set the threshold at 95 percentile of the reconstruction error on normal transaction. This means that 95% of normal transaction have an error below the threshold. Okay. By selecting 95 percentile, we consider transaction with reconstruction error higher than this will value to be potential anomalies. Okay. So what were we doing? We get this. So we have got the reconstruction errors. So this is the reconstruction errors. This is the reconstruction error actually. Yes, this is the reconstruction error. So if we see here the reconstruction error, what are we going to see? So for each, what are we doing here? Where the reconstruction error is 90 for all the so by selecting the 95 percentile, we consider transaction with reduction reconstruction error higher than the this value to be potential. So the if the reconstruction error is, so we have got the reconstruction error like this. So see, we don't have any negative value now. Okay, so we have got the reconstruction error for each of the, yes, it is close here, and the reconstruction error we have got this. Now we see the reconstruction error. What are we going to do? We'll do what? I'm repeating the same sentence again and again. So I guess maybe the fever is speaking. Yeah. So we are doing what? Let's write it down. I understood, but I'm not able to explain it to you guys. Threshold. So we say the threshold. We do percentile. Okay. Here we are going reconstruct error where the y validation is equals to 0 and we are doing 95 percentile. So what are we doing? If you remember, we had two values in our y val. Y val is the target value, whether the transaction is an anomaly or non-anomaly. So we are taking only those whose whose we are only taking the ones whose y val, which is originally uh, they were what, they were normal transactions. They were what, they were normal, sorry, yeah, they were normal transactions. Okay, so we are taking only the ones which are normal transactions, and then we are calculating the threshold for them. Then we are calculating the threshold, so we are taking the normal transactions only, and out of the normal transactions we are calculating the percentage, that is out of 95 percentiles. So threshold for anomaly detection is, now let's print it. Threshold for anomaly detection is threshold. Let's print it and then go to the last step 3. With the threshold set, we classify transaction as normal and anomalous. So okay, now it is checking the threshold. Okay, so what are we doing? We are doing if error we so is greater than threshold, uh, it is anomaly, it is a normal, it is a for fraudulent transaction, else it is a normal transaction. For error in the, okay, so we are iterating the reconstruction errors, and then for each error, if the error is greater than the threshold, it is this one, otherwise it is this one. So y prediction, what are we doing? We are doing what? 1. So what we are doing for error in reconstruction errors. Okay, what are we doing with errors? uh, if if error equals, if error is greater than threshold, we have calculated the threshold, then the prediction will be 1. It is an anomaly, that transaction is an anomaly, else 0. Cool. Now what are we doing? Print actual labels for evaluation, actual labels for evaluation. What are we doing? What are we doing? Okay, so we are printing how many were actually present in and how many the model has predicted. So print actual anomalies, sum of y and detected y sum of y prediction. So it will give us the values which are 1 and it will add up them. Okay. And then we are going to see the classification report and the confusion matrix. So for that, let's import from sklearn dot sklearn what matrix import classification and confusion matrix, and then we are going to import that evaluate the model's performance. So what are we going to do? Cla- confusion matrix is confusion matrix of the y value and y actual values and the predicted value prediction. uh, Print confusion matrix is confusion matrix, and then we are going to say classification report classification report of the actual value and the y prediction. Classification report, classification report. Let's put it in the new line, and this also, and yes, and yes. Now let's do what? Let's run the code. We are almost done with the code. I do want to see the threshold, so it will print the threshold. It will print the reconstruction errors also. So reconstruction errors are what it is doing. It is printing the mean, and it is printing the power of 2, so that, sorry, Mhm. Let it run. So we have understood till now, but I still kept it open, so because I wanted to see what is in this. So we did get the prediction value, and from the prediction value, what we did, we created a reconstruction error for each transaction. We did that because we wanted to do what? We wanted to avoid the negative values, so that they do not cancel out the negative values. That is why we did this. So we calculated the mean square error. Actually, we calculated the mean square error for each input sample. That is the reconstruction error. Now we calculated the mean square error. Now we wanted to calculate the threshold. Now threshold is that the value needs to have 75%. So what we did, we got the 75% of what? 75% of the the construction errors. So if the error is going to be greater than threshold, it is anomaly. It is, otherwise it is not. So the threshold that came. So this is the model, that how it performed. It started with 0.5775 loss, and validation loss 0.64, 75 and 64, and it stopped at 0.42, 75 to 42, great improvement. And validation also not that great, but yes, it also gradually decreased. So good thing here. Now this is how the reconstruction errors for each transaction look like. This is the mean squared error. Now uh, if so, mean squared error, the threshold for anomaly detection is this. So if uh, any any error is any of this value is greater than this, it is going to be a anomaly. Okay, so for example, this is an anomaly for sure. This is not an anomaly, 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 this is not an anomaly. So if we check here, actually anomalies detected was 98, what are 98, but the sorry, actually anomalies were 98, but our model has detected 2938 anomalies, which is very bad performance. So the confusion matrix is also not good. The model is performing not that great. So this is the output. This is the output. I think is not performing that great. What do you say? It has lots of false positive here. It has lots of false positive here. See, it has predicted 2844 as anomalies, but they are not anomalies. So it has lots of false positive. Uh, Let me see what this has to say. You are correct. The output metrics show that the current and autoencoder model is not performing well for anomaly detection. It says that let's dive into what these metrics are telling us and explore why the model's performance might be lacking, and also what we can do to improve it. The threshold is this. Maybe we need to increase the threshold. See, I told you lots of false positive, right? Precision recall value very less precision. It is very low. It is relatively good, 98%. It is indicating that a large portion of the transaction flagged as fraud, they were actually normal. So the precision is very bad. So why, what could be the case that the model is not performing well? Well, because if you remember, if I go here, what database are we using? If I go here, if you read a little about this data set, it will clearly tell you that the data set is highly imbalanced. The data set is highly imbalanced. So that is one of the reason that why it is not performing good. So that is the reason is typically highly imbalanced. The number of normal transactions greatly exceed the number of fraudulent ones, which can make it difficult for a model to correctly classify frauds without generating a lot of false positive. Correct. So that is the case here. And then threshold sensitivities. The thresholds set for reconstruction error plays a crucial role in determining anomalies. The threshold value 1.0 was set based on the 95 percentile of the normal data. Okay, so this is what it is doing. If we go here, what is the 90 value that 95 percentile of the values are coming here? It is coming here as 1.00147. It seems that the threshold is too conservative, leading to many normal transactions being incorrectly flawed as fraud. So one of the reasons and are I'm thinking is highly imbalancing nature of the credit card fraudulent data set that we are using. If we go ahead, clearly says that we did read it right. See, the data set is highly unbalanced. The positives, that is frauds, account for 0. Not even 1% of the transaction. So that is why the model is not performing that great. But yeah, overall what we have understood uh, a lot about the model today. We have understood what and how this autoencoder can be used. So I'm going to go and uncomment it. I'll comment this, keep it open. So yeah, we have understood how to build and code the model and build the reconstruct the layers again. Why we did on the normal transaction only, and then how we fine tuned it, and then we validated the performance. So all in all, it is a good learning. So yes, I'll conclude it now. So I'll say git status, git add day 20, git commit day 21 code, push main origin main. What I'm thinking of changing the name to git 20. I'll change the name to move day 20 to day 2021.py, and I'll do what, open this thing, close it, add it. Let's add this, add day 2021 py. Let's do git status, get remove day 20 dot, not remove this. So we should have, yeah, we had just renamed it. Let's commit this, change the name of day 20 code main. Let's push it to main. Let's see if we can find the file here. We have the file here. So yes, we are done with the week 4 only also. Not this one, sorry, week 3 also. Now we'll come back tomorrow and start exploring a new thing, a completely new thing called GANs. I don't know what it is about. transformers, and advanced topics. So it is going to be an exciting time, a week. I'm hoping to get well, and then I can focus and with more energy. One more thing, when I was solving this is just for me. I'm thinking of changing the flow a little. So once I'll be done with this thing, I'll focus on working on week long or a month long, let's say week 2 week long projects. And then in those projects, what I'm planning to do is, instead of me recording myself, I'll put up two videos. First is myself recording and actually working on it, and the second video is where I'll just give you the sneak summary of what we did. So this is going to help those who do not want to just go and watch the full video, and anyone who is not interested in watching the video. They just can go watching a hour long video. They can go and finish, understand the topic within like a couple of minutes, 7 to 8 minutes max. So yes, this is what I'm targeting to do. Thank you very much. Let's come back tomorrow and finish this challenge with more energy. Thank you.